Hi to everyone, dear friends and delegates and my dear friends. Today we are discussing about applied engineering mathematics 3 under the topic differential equations. The subtopic is homogeneous differential equation. In, uh, in this before of this session, we will discuss about variable separable method. So we will discuss in this session what is the homogeneous function, what is the homogeneous differential equation. First, we have learned about these two definitions. So, see here. So, today's learning objectives are on the completion of this topic, we would be able to define the homogeneous function. What is the homogeneous function? I will give the definition and define the homogeneous differential equation. What is the homogeneous equation? We will define in this session. Okay, solving homogeneous differential equations. In this session, we will discuss about the three topics. So now we are discussing homogeneous differential equation. Homogeneous differential equations. See here. So I will give the definition. Homogeneous function. What is the homogeneous function? I will give the definition. A function f of x comma y is said to be homogeneous function in x and y of degree n if f of kx comma ky is equal to k to the power of n into f of x comma y for all k values. For all k values. I will repeat once again. A function f of x comma y is said to be homogeneous function in x and y of degree n if kx comma ky is equal to k to the power of n into f of x comma y. Okay, so k to the power of n into f of x comma y for all k, where n is the constant. This is the homogeneous function. Okay, if f of if a function f of x comma y is said to be a homogeneous function in x and y of degree n if f of kx comma ky is equal to k to the power of n into f of x comma y. We have to take common k to the power of n from the given function. So this n is the constant. This n is the degree of the homogeneous function. So now this is the homogeneous function. So next, I will give some example on homogeneous function. See here, let us see here. F of x comma y is equal to x square plus y square by x cube plus y cube. Then f of kx comma ky is equal to kx whole square plus ky whole square by kx whole cube plus ky whole cube. From the numerator, we have k square common, and denominator also you will get common k cube. So take common from numerator k square, from denominator k cube. So cancel this k square, you will get in denominator k times. So k take in numerator, you will get k to the power of minus 1. K to the power of minus 1. So this function it can be written as k to the power of n into f of x comma y. So this is a homogeneous function of degree minus 1. Okay, this is the form. This is the homogeneous form. So the function f of x comma y is a homogeneous function of degree minus 1. So I will explain once again. Let f of x comma y is equal to x square plus y square by x cube plus y cube is the x cube plus y cube is the given function. We have to show this is a homogeneous function. Okay, so here x is replaced by kx and y is replaced by ky. On right side also same, kx whole square plus ky whole square by kx whole cube plus ky whole cube. So in from numerator you have to take common k square, then you will get x square plus y square. In numerator also same, you will take common k cube, you will get x cube plus y cube. So after cancellation of these k terms, you will get in denominator k. You will take in numerator. So this will be k to the power of minus 1, f of x comma y. So this function can be written as f of kx comma ky is equal to k to the power of n into f of x comma y. So this form is known as homogeneous function. So here k to the power of minus 1 means this minus 1 is the degree of the homogeneous function. Okay, this is a homogeneous function of degree minus 1. I hope you are understood. So I will go another problem. See here. So here the given function is f of x comma y is equal to x square plus 3xy plus y square is 2y square is given. Under this function, we have to substitute, we have to show this homogeneous function. That means we have to substitute k by kx and y is replaced by ky. On right side also, you will replace k value kx and y value ky. So on right side, all the terms contain k square. That's why we have take common k square. Then you will get x square plus 3xy plus 2y square. Okay. So after taking common k square, this function is becomes f of x comma y. So this x square plus 3xy plus 2y square is replaced by f of x comma y. So here we are taking common k to the power of 2. This 2 is indicated the degree of the homogeneous function. This form is called the homogeneous function. Okay. So here, hence the f of x is a homogeneous function of degree 2. Okay. So this is the second problem. So I will go to third problem. See here, f of x comma y is equal to x square plus y square by x plus y. X square plus y square by x plus y. So here in numerator, powers 2 plus 2 is 4. Numerator having the power 4. In denominator, here is only 1. The single terms power 1. So ultimately you will get the degree of the homogeneous function 4 minus 1, you will get 3. Directly we have to help. Okay. So we have to show this function is homogeneous function. So you have to substitute in the function kx is replaced by kx and y is replaced by ky. On right side also same, kx whole square to ky whole square by kx plus ky. In numerator, you have k square into k square. You will get k to the power of 4. So here is some mistake is there. Here is 2 is replaced by 4, but it is spelling printing mistake. So k to the power of 4 into x square plus y square by k into x plus y. K into x plus y. This is equal to k into x square plus y square by x plus y. Okay. So k to the power of something is taken common here. Here k cube. Here k to the power of 4. Here k. K one time cancel. You will get 3 times. So you will get here k cube power 3. Okay. Is it clear? So now f of x comma y is homogeneous function of degree 3. Is it correct? Degree 3. So are you clear? So how to show the given function is homogeneous function means first you have to substitute k is replaced by kx and y is replaced by ky. After simplification, we will get k to the power of something. So this function is in the homogeneous form. This k to the power of something is the degree of the homogeneous function. Is it clear? So see example 4. So I will give one example. Is it homogeneous or not? We have to check now. So the given function is f of x comma y is equal to sin x plus sin y. In this function, we have to substitute kx, x is replaced by kx and y is replaced by ky. And right side also same, sin kx plus tan ky is not equal to k to the power of n into f of x comma y. So k to the power of something not taken common from this trigonometric function. Here is a sine function, here is cos function. We cannot take k to the power of something function. So that's why this is not a homogeneous function. F of x comma y is not a homogeneous function. Okay, is it clear? So the above functions are homogeneous functions, and this function is not homogeneous function. So see another definition too. A function. So before of this definition, we are discussing about homogeneous function. This definition is homogeneous differential equation. See here, a function f of x comma y is said to be an homogeneous of nth degree if it can be put in the form of x to the power of n into f of y by x or y to the power of n into f of x by y. This is the alternate definition of the above homogeneous function. Okay, I will repeat once again. A function f of x comma y is said to be homogeneous function of the nth degree if it can be put in the form x to the power of n f of y by x or y to the power of n f of x by y. We have to show in the form, then the given function is a homogeneous function. This is the alternative definition of the above definition. So I will give one example here. See here, f of x comma y is equal to ax cube plus by 3b x square y plus cy cube is the function in the variable x and y. So now we have to show this function is homogeneous or not. We have to check. So by above method we have to solve. So I will tell another method. So see here, from the RHS side, we have to take common x cube from all terms. So here x cube is taken common. We have here only a term. In this function, we have middle term. We have only x square. We are taking x cube. We have in denominator only x. X square is there. We are taking x cube. That's why we are dividing with the x. Plus in the third term, there is no x variable. So we divide with x cube. This can be written as y by x whole cube. X cube is there. After taking common x cube, the term will be becomes a plus 3b by y by x plus c into y by x whole cube. Okay. Now this can be written as x cube into f of y by x. X cube into f of y by x. So the function can be right in this form. So then this function is a homogeneous function. So also we have to take common y cube also. Similarly, in the same manner, in the same process, we have to take common y cube from the above function. We have to take common from above function y cube. You will get here c, and the middle term you will take common here y. You will get here y square denominator, and the first term you will take here is not contain the y term. So that's why you are dividing here y cube. So here is after taking common y cube, this will be get. Okay, c plus 3b into x by y whole square plus a into x by y whole cube. Okay, so now this can be written as f of x by y. We are taking here y cube. This can be written as y cube into f of x comma y. So these these functions are homogeneous function. The above equation can be written as in the form of x cube into f of y by x or y cube into f of x by y. So we have to show these terms when the above equation is homogeneous differential equation. This is the alternative method for showing the function homogeneous function. I hope you are understood. This is the alternate method for the above problem. Therefore, f of x is a homogeneous function of degree 3. Okay. So next we have to discuss homogeneous differential equation. Before of this definition, we have to discuss homogeneous function. Homogeneous function. What is the homogeneous function we will discuss? This is homogeneous differential equation. We are discussing before this function homogeneous equation. Now we are discussing about homogeneous differential equation. Okay, right. So a differential equation of the form dy by dx is equal to f of x comma y is said to be an homogeneous differential equation if f of x comma y is an homogeneous function. It must be an homogeneous function of degree in x and y. And see here, its degree must be 0. Okay, right. I will explain once again. A differential equation of the form dy by dx is equal to f of x comma y is said to be an homogeneous differential equation if the function f of x comma y is an homogeneous function of degree 0. When the function degree is 0, this function uh, this function is an homogeneous differential equation. Compulsory, it must be 0 of the homogeneous function. Then the equation becomes the homogeneous differential equation. So I will give the one example. See here, f of x comma y is equal to xy by x square plus y square. Okay, this is the example for the above equation. See here, in numerator you have x power 1 and y power 1. This 1 plus 1 you will get 2 here. In denominator also you will get 2 here. So 2 to get cancel. Here degree of the homogeneous function is 0. So this is the homogeneous differential equation. Example of the homogeneous differential equation. So f of x comma y is homogeneous function of degree 0. So homogeneous equation, types of homogeneous equation. So here is two types of homogeneous equations are there, differential equations are there. The first type is dy by dx is equal to f of x comma y. Here we are differentiating the function y with respect to x. The function y with respect to x, we will get f of x comma y. This is the one type of differential equation. The another type is dx by dy is equal to f of x comma y. Here differentiating the function x with respect to y. In this equation, we will differentiate the function y with respect to x. These are two types of homogeneous differential equations are there. Okay. Next, I will give the homogeneous differential equation and the definition. See here, a differential equation in x and y is known as homogeneous if it can be put in the form dy by dx is equal to f of x comma y, f of x comma y, f of x comma y by g of x comma y, where f of x comma y and g of x comma y are both homogeneous functions of the same degree in x and y. I will repeat once again. A differential equation in x and y is known as the homogeneous if it can be put in the form of dy by dx is equal to f of x comma y by g of x comma y, where f of x comma y and g of x comma y are both homogeneous functions of the same degree in x and y. So this function degree will be same. So this is the homogeneous differential equation definition. Okay. Next, we will solve some problems on this method. So methods of solving a homogeneous differential equation. Okay. Next is let the given homogeneous function be dy by dx is equal to f of x comma y by g of x comma y. Name this equation number 1, where f of x comma y and g of x comma y are both homogeneous functions of the same degree in x and y, so that this equation can be written as f of x comma y is equal to x to the power of n into pi 1 of y by x and g to the power of g of x comma y equal to x to the power of n into pi 2 of y by x. This name this equation number 2. So now from this two function can be write in this form. So from equation number 1 and equation number 2, solving from equation number 1 using this equation number 2 and equation number 1, the equations is reduces like this: dy by dx, this f of x value, by 1 y by x, and this g of x value by 2 y by x is equal to f of y by x, f of y by x. Okay, so in this equation we have to put y is equal to vx, so that the equation becomes, after differentiating this y is equal to px, we will get dy by dx is equal to v plus x dv by dx. Here applying the formula product rule of differentiation. So v is constant, derivative of x value is 1, plus x is constant, derivative of v value is dv by dx. Here dy by dx. After differentiating, you will get this equation. So now equation 3 becomes, the above equation 3 becomes v plus x dv by dx is equal to f of v. So this v can be taken on other side, then you will get x dv by dx is equal to f of v minus v. So now after variable separable, you will separating the variable, you will get dv by f of v minus v is equal to dx by x. So now here variable is separable is completed. Now apply the integration, you will get the required solution. After getting the solution, we have to substitute the v value here, y by x, you will get the desired solution. This is the process of finding the differential equation. Okay, this is the procedure how to solve the differential equation. So I will explain once again. See here. So method of solving the homogeneous equation. Let the given homogeneous equation be dy by dx is equal to f of x comma y by g of x comma y. Name this equation number 1. Okay, name this equation number 1. So now, where f of x comma y and g of x comma y are both homogeneous functions. These are both homogeneous function of degree same in x and y. If this is possible, the degree of f of x comma y and the degree of g of x comma y is same in the variable x and y. So this equation can be written as f of x comma y is equal to x to the power of n into pi 1 of y by x, and g of x comma y is equal to x to the power of n into pi 2 of y by x. After taking common here x cube, after taking common here y area. Okay, from these two equations 1 and 2, the equation reduced dy by dx is equal to pi 1 by y by x, here x to the power of x to the power of x cancel, and by pi 2 of y by x. This can be written as f of y by x. Okay, so next put y is equal to vx, so that the equation becomes dy by dx is equal to v plus x dv by dx. So after differentiating this y is equal to vx, so that dy by dx is equal to v plus x dv by dx, v plus x dv by dx. So now equation 3 becomes v plus x dv by dx is equal to f of v plus x dv by dx is equal to f of v. So after taking this v and right side, then you will get x dv by dx is equal to f of v minus v. So dv by f of v minus v is equal to dx by x. So now it is a variable separable. Separate the variable. Now it is ready to integrate. After integrating, you will get the solution. In this solution, we have to substitute the y value, v value, y by x, then obtain the desired solution, which can be easily integrate in the solution. Put y is equal to v is equal to y by x to obtain the desired solution. Working rule for solving a homogeneous equation. So I will tell the steps how to find the homogeneous, how to solve the homogeneous differential equation. First step, put the given equation in the form of dy by dx is equal to f of y by x. First we have to convert the equation is in the form or dy by dx is equal to f of x comma y by g of x comma y. Then where f of x comma y and g of x comma y are both homogeneous functions of degree n. So step 2, put y is equal to vx so that after derivating of this function, we will get dy by dx is equal to v plus x dv by dx. Okay. Now substitute this equation in the above equation. Then the third step is substitute the value of y and dy by dx in the given equation. The reduced equation involves v and x only. After substitution of this equation, we will get the reduced equation, the variable v and x only. The fourth step is solve the new differential equation obtained by using the variable separable method. Okay, next solve the new differential equation obtained by using the variable separable method. Step 5, in the solution obtained in step 4, replace v by y by x so as to obtain the required solution. This is the step 5. So I will explain one problem. This is the first problem. How to solve this? Solve x square by into y dx is equal to x cube plus y cube into dy. So given equation can be written as x dy by dx is equal to x square y by x cube plus y cube. So this is the homogeneous equation in the variable x and y. Put y is equal to vx. So then the equation becomes dy by dx is equal to v plus x dv by dx. Substituting the values of y and dy by dx values, the above equations, then the equation becomes v plus x dv by dx. This is the dy by dx. And right side we have to substitute y is replaced by vx. So take common x square from numerator and take common x cube from denominator. X into x, x cube, x square into x cube numerator. After cancellation of this x square x term, you will get v by 1 plus v cube. So the reduced equation becomes in the variable x and v. See here, after taking of this v on right side, then you will get this minus v. So taking LCM this two, then you will get v minus v to the power of 4 by 1 plus v cube. So after cancellation of these two terms, you will get minus v power 4 by 1 plus v cube. 1 plus v cube. Okay, is it clear? So this equation, after subtracting the variable, the equation becomes minus 1 plus v cube by v to the power of 4 into dx. On right side, you will get only dx by x only. Okay. Next, separate the denominator of these two terms, then you will get minus 1 by v to the power of 4 minus 1 by v into dv is equal to dx by x. So on integrating on both sides, we get integration of minus 1 by v to the power of 4 minus 1 by v into dv is equal to, on right side you will put integration sign dx by x plus c. So now it is ready to integrate. So integration of minus 1 by v power 4 using the formula x to the power of n formula, then you will get 1 by 3v cube. This is in the form of integration of log x. You will get log v. This is equal to integration of dx by x. 1 by x into dx is log x. So these two terms in the logarithmic form. That's why we are substituting this c also in logarithmic form. Okay, is it clear now? So now log v plus log x minus log c is equal to, on right side you will get only 3v cube. After taking off this term, right side to left side, this will get. So by properties of logarithms, log a plus log b is equal to log a into b, and log a minus log b is equal to log a by b. Using the two properties, this will becomes log of Vx by C is equal to 1 by 3V cube. Log of Vx by C is equal to 1 by 3V cube. Okay, by replacing the value V by Y by X, we get in this equation y by x. Substitute v value y by x, this x cancel, then you will get y by c is equal to x cube by 3y cube, x cube by 3y cube. So now this log take on right side by the definition of logarithmics, you will get e to the power of something. Okay, e to the power of x cube by 3y square. This is by definition of logarithms. Okay, so after cross multiplication of this c, the equation becomes y is equal to c into e power x cube by 3y cube, which is the required solution. Which is the required solution. I hope you are understood. So I will explain once again. Okay, this is very important problem. So see the problem 1. So example 1, solve x square into y dx is equal to x cube plus y cube into dy. Solution is, given differential equation, you will write once again dy by dx is equal to x square y into x cube plus y. After simplifying this one, you will get this. Okay, this can be written as dy by dx is equal to x square y into divided by x cube plus y cube. This is a homogeneous function in x and y. How? See the numerator. In numerator, you will have the x power 2 and y power 1. So total power is 3. In denominator, you will have the power 3. Numerator power, denominator power is equal to, you will cancel that. Then the degree of the homogeneous function is 0. That's why this is the homogeneous function. If this function is a homogeneous function, is it clear? Then after you have to put y value vx in this equation. So we are putting y is equal to vx. Then we have to integrate the function y is equal to vx. Derivative of y is dy by dx. On right side, the product rule. After the product rule, you will get v plus x dv by dx. Okay. So substituting the values of y and dy by dx. Substituting the values of y and dy by dx in the given equation, we will get v plus x dv by dx is equal to x square. Now substitute here vx y value, v substituting here the above, v is equal to yx, y is equal to vx here. So then the equation becomes here right side dy by dx value, substituting here v plus x dv by dx. On right side, substituting y is equal to vx. Then the equation becomes x into x cube, x square is x cube. Denominator take common x cube. This x cube get cancelled. Then you will get v by 1 plus v cube. V by 1 plus v cube. So now this v term take on right side, we'll get here minus v. After taking LCM, you will get this one, v minus v to the power of 4 by 1 plus v cube. This is equal to minus v to the power of 4 by 1 plus v cube. So cancel this v and v minus v. Then you will get after separating the variable, then you will get minus of 1 plus v cube by v to the power of 4 into dv on right side dx by x. Okay, this is now separating the variable. Now it is ready to integrate. So now divide the denominator is separate to the two terms. You will get minus 1 by v to the power of 4 minus 1 by v into dv is equal to dx by x. So now integrate on both sides. Then you will get integration of minus 1 by v to the power of 4 minus 1 by v into dv is equal to integration of dx by x plus c. Okay. So now this is in the form of x to the power of n. Apply the formula x to the power of n formula. After taking this function in numerator, you will apply formula x to the power of n. Then you will get 1 by 3v cube using by x to the power of n formula. Here integration of 1 by x is log x, and right side integration of 1 by x into dx is log x. Now you have to substitute this c value log c. Why? Because we are getting we are getting two logarithmic function here. That's why we are putting here log c after completion of integration. The log c is the constant function. Okay, log v plus log x minus log c is equal to 3 by v cube. So now here is using some logarithmic function. Log a plus log b is equal to log a into b, and log a minus log b is equal to log a by b. Using the two properties, this will becomes log of vx by c is equal to 1 by 3v cube. Okay, then after take this log on right side by the definition of logarithm, so it will becomes e to the power of something. So now here replace v value, v is equal to y by x, substituting this equation, then the equation becomes log of you are substituting y by x, x cancel, you will get y by c, and right side also substitute here v is equal to y by x. After simplification, you will get x cube by 3y square. Okay, then the logarithmic term take on right side by the definition of logarithm, it will becomes e to the power of x cube by 3y cube, 3y cube. So now after cross multiplication of this c terms, the equation becomes y is equal to c into e to the power of x cube by 3y square, which is the required solution of the above differential equation. In solution consists to only constant variable, arbitrary constants. Okay, is it clear? I hope you are understood this problem. I will go to another problem now. So see the other problem. dy by dx is equal to y by x plus tan y by x. Name this equation number 1. So the given equation, write once again, dy by dx is equal to y by x plus sin y by x is equal to 1. So put in this equation y is equal to vx, then the equation becomes after differentiation of y is equal to vx, we will get dy by dx is equal to v plus x dv by dx, v plus x dv by dx. So now substituting the values y and dy by dx value, y, this y value and dy by dx value, substitute in the above equation. So we will get here v plus x dv by dx. From this equation, here substituting dy by dx value. Okay, on right side v plus sin v, v plus sin v. So on both side v term is same. Cancel the both side v term. Then you will get x dv by dx is equal to sin v. Okay, separating the variables, you will get dv by sin v is equal to dx by x. It is ready to integrate. So now we have to take in the sin v numerator, we will get cos v. So see here, so integration of dv by sin v is equal to integration of 1 by sin x. So now this 1 by sin v can be written as cosec v into dv. It is ready to integrate now. So integration of cosec v is log tan v by 2. Log tan v by 2 is equal to, here already integration is completed. We are putting here logarithmic constant on integration constant also. So log a plus log b is log a into b. In both sides, log is cancelled. So here log take this side, we will get e to the power of log. E to the power of log value is 1. Then the equation becomes tan y by x is equal to xc. Tan y by 2x is equal to xc. This is the required solution of the above differential equation. I hope you are understood. So I will explain once again this problem. See here, the given problem is dy by dx is equal to y by x plus sin y by x. This is the given problem. We have to solve this differential equation. Now the solution is the given equation is write once again in this equation number 1. Now in this equation we have to substitute the y value vx. After derivating of this function, you will get a dy by dx value. That value also substitute here. So after derivating of the function y is equal to dx, we will get dy by dx is equal to v plus x dv by dx. Okay. Next, substituting the values y and dy by dx values in equation number 1, first equation, we will get the equation becomes v plus x dv by dx. This value, v dy by dx value is v plus x dv by dx. Substituting here. And right side, v plus sine v. V plus sine y by x becomes v. Here y by x becomes v. So on both sides v cancel, then you will get x dv by dx is equal to sine. Separating the variables, then you will get dv by sine v is equal to dx by x. So see the two sides. On left side we will have only v variable, on right side we have only x variable. It is variable separable. Okay. Then integrating on both sides, then you will get integration of dv by sine v is equal to integration of dx by x. Okay, is it clear? So now this 1 by sine v in written has cosec v to dv. Integration of cosec v dv is equal to, so here integrating of 1 by x is log x. Integration is completed. In putting here logarithmic constant, integration constant log c. So on right side, log x plus log c becomes log x into c. On left side, integration of cosec v can be written as log tan v by 2. Log tan v by 2. So here, log tan v by, y by x, substituting here y value, v value, y by x. You will get y by 2x. Okay. Next, on both sides, log get cancelled. After taking up this log function on right side, you will get here e power log. E power log value becomes 0. You will get only here xc, cx. So here tan y by x is there, and right side you will get cx. So this is the required solution for the above differential equation. Is it clear now? So in this session, we have learned 3 points. So first we are discuss about the homogeneous function. Define the homogeneous function. What is the definition of homogeneous function? I am giving two definitions in this equation, in this homogeneous function. So first and second. Okay. So the second one is homogeneous differential equation. First point is homogeneous function. On this topic, I will given two definitions and examples also. The second point is homogeneous differential equation. I will given definition also. I have solved some example problems also on this topic. So next, the third one is general solution of the homogeneous function. This is also completed. These three topics we are discussing in the today's session. So I will give some these questions. See the questions. So a homogeneous differential equation of the first order and first degree can be solved by putting dash. Homogeneous differential equation. We can solve the homogeneous differential equation. They are putting y is equal to or v is equal to. From these three choices, what is the correct answer? Now you have to choose. Choose here. A is equal to option A is y is equal to vx. Option B is y is equal to v by x. Option C is y is equal to x by v. In these three, what is the correct solution? We have to find. Okay. See here, answer is y is equal to vx. Here, blinking here. So the second question, the equation x square minus 2y square plus 2x square dy, 2xy into dy by dx is equal to 0. This differential equation is homogeneous function. Option A is not non-homogeneous function. Option A, homogeneous function. Option B, exact. Option C. In these three options, which is the correct solution? Is it homogeneous or non-homogeneous or exact? Okay. Next, today assignment. I will give some assignment. So solve 2x plus 2y into dx plus 2x plus y into dy is equal to 0. This is the today assignment problem we have to solve. The solution also given here. The solution is x square plus 4xy plus y square is equal to 0. solve the above method, solving of differential equation, use the above problems. In the same manner, you have to calculate this problem, you will get this answer. Okay, the second problem is x dy minus y dx is equal to under root of x square plus y square into dx, given that y is equal to 0 when x is equal to 1. So conditions also given here. So now you have to solve this equation. You will get the solution y plus under root of x square plus y square is equal to x square. Okay, so this is the solution for the second question. So I hope you have to solve these problems by using the above problems what we have solved in the session. Okay, next, previously asked for some more questions are there. So this is the questions. See here, solve dy by dx is equal to y by x plus sin y by x. This is the question in previous coming question. And second question is solve y into x plus y into dx, x into x minus y into dy is equal to 0. This is also you will get in previous question. You have to see the previous paper, you will get these questions. Okay, thank you. Thank you everybody. I hope you are understood very well. So before of this session, we are solving the variable separable method. In this session, we have to solve the homogeneous functions. If not possible to solve the uh, variable separable method, then we have to substitute y is equal to bx and dy by dx value also substitute. Then we will get the variable separable option. Then you have to solve. Okay. I hope you understood very well. Thank you everybody. Have a good day. Thank you very much.